So today we're going to talk about combinations. Okay, so we talked about permutations the other day, so today's combination. Now combination is similar, except for it's an arrangement or listing in which order is not important. So permutation, remember, is an arrangement in which order was important. And so this is why it's kind of funny that we talk about the combination in your lock. I mentioned this in the notes the other day. That the combination in your lock, the order in which you dial in your numbers is important, but yet we call it a combination. So it's kind of funny the way we use that. It should be called the permutation of your lock. So feel free to be the uber nerd and tell all your friends that next time they dial in their permutations into their locker. So let's do an example here. So just to kind of demonstrate what I'm referring to. So it says, choose 3 letters from A, B, C, D. If order does not matter, how many different combinations are there? Well, what that means is, if I were to choose 3 letters, let's say A, B, and C. Okay? Now, A, B, C, if order doesn't matter, means the same thing as CBA, means the same thing as BAC, means the same thing as BCA. So all of those things, all those different choices here. Now there's more, okay, but all these, according to a combination, are exactly the same thing as this. So we don't list any of these. So what's another one? Well, A, B, D. A, D, C. D, B, C. So there's actually only 4 different combinations that you could list 3 of these letters. Okay, if the order doesn't matter. Okay, so that part's really, really important. If the order doesn't matter, there's actually only 4 different ways you can pick 3 of these things. Okay, so obviously a much smaller amount. Now, how would that answer differ if order did make a difference? Well, that would be a permutation. Okay, well, that if you remember, that's where we went through and said, all right, well, you have 4 choices for the first one, you have 3 choices for the second one, and then you have 2 choices for the third. So there'd be 24 different arrangements. Okay, so because permutation tells us that order matters, picking A and then B is different than picking B than A. But in a combination, it doesn't make a difference. Okay, good examples of combinations would be like picking a basketball team, picking 5 guys to start for your basketball team. Doesn't matter what 5 guys you pick. Okay, if you pick person 1, 2, 3, 4, 5, or if you were to pick 5, 4, 3, 2, 1, they're all 5 starters. They're all on the basketball team. Picking different ways in which you can put stuff on. Let's say you're like your pizza. It doesn't matter if you put sausage and then pepperoni and then green peppers on, versus if you were to put green peppers, sausage, and then pepperoni. You get the same result. So those are different examples of combinations. Now, combination, very similar to a permutation, has a nice simple little formula for us to use. Okay, and here it is. It says the number of combinations of n distinct objects taken r at a time is defined as this. Now, just like on a permutation, this is actually already programmed into your calculator. Now, we'll talk about how to do that here in just a second. But again, this is talking about n is the number of objects you're choosing from, while r is the number of objects you are picking. Okay? So let's do an example. All right. So it says how many 6-player flag football teams can be chosen from a 14-player pool. So this is a good example of a combination. And so what we can do, and we'll just jump right to our calculator here, but in just a moment. So what we're doing is this. We're doing C. There's 14 to choose from. There's 6 that we're going to pick. So that would be 14 factorial over 14 minus 6 factorial. Whoops, 6 factorial. Which would be 14 factorial over 8 factorial, 6 factorial. Now what does that equal? Well, let's see. If I were to do 14 factorial divided by 8 factorial 6 factorial, I'd get 3,003 different teams I could pick. Now, as I told you, your calculator does that for you though too. In a lot of yours, you have this probability button, and so what I would do is I would just do 14, hit the combination button, 6 is what we're doing, sorry. And so what I would get? 3,003, just like we did. So your calculator already has this this formula programmed into it for you. Okay, let's do a tough one. In the mood for a tough one here. So it says, in this one, it says, from a group of 10 men and 12 women, how many committees of 5 men and 6 women can be formed? All right, so this one's a little complex because we have committees of 5 men and 6 women that are going to be chosen independently of each other. So what does that mean? Well, what that means is we have 2 different combinations going on. It means we have this situation where we have 10 men, we're going to choose 5. We also have this situation where we have 12 women, and we're going to choose 6. So, and by the way, another way that you could write this 10C5 and 12C6. Notice these are subscripts here. Okay, and so how would I do that? Well, I would just take my calculator, and I would do 12C6 for the women, so 924. I would do 10C5 for the men, 252. And then what I would do then is, because for every one of these combinations, there's 924 of these that go with it, you multiply them together. So I would take that 252, and I would multiply 924, and we'd end up with 232,848 different possible committees. And again, the reason why you multiply that is if you were to figure out one combination here, there's 924 of these that go with it. Then you figure out the second one, there's another 924 that go with that one. Pick out a third, 924. So basically you're taking this 924 and multiplying it by all those. Okay, so that's why we multiply that. So, okay, that's the general idea behind the combinations. Not terribly difficult. The part that does get tough sometimes is the wording with the examples, but we'll talk about that more in class. So as always, if you have questions, make sure you bring them to class. All right, thank you.